This is for Year 12 Specialist. It comes out of Chapter 13A, question number 12. But it's actually out of vectors back in Chapter 2. So find the component of the force of this in the direction of this vector. So I've got this vector which goes across 2 down 1, so it's in that direction. And I have this vector which is 7 across and 3 up. So I've got to change my 7 across and 3 up into a vector in the direction of this one and one that's perpendicular to this one. In actual fact, this is vector resolutes. So I'm going to use the resolute of vector A in the direction of vector B, and I can use any of these forms. Okay, so I want to find the vector resolute of A, which is 7i plus 3j, in the direction of B, which is 2i minus j. That's what the question's actually asking. So I'm going to use vector resolutes. And the formula is, let's use this one. So A dot B is going to be 7 times 2 is 14, plus 3 times minus 1 is minus 3. That gives me 11. The magnitude of B is going to equal 3 plus 1. 2 squared is 4 plus 1, so it's going to be root 5. But the magnitude of B squared is 5. So it's going to be 11 on 5 times B, which is 2i minus j. And that's going to be the vector resolute of the force in the direction of that vector. And looking at the second one, find the component of this force in the direction of that vector. I'll do the same thing. I'm going to call that A. I'm going to call that B. So A dot B will equal 2 times 3, which is 6, plus minus 3 times 4 is minus 12, so negative 6. The magnitude of B will be 5, because 3 squared is 9 plus 4 squared is 16 is 25 square root. The magnitude of B squared is going to be 25. So I'm going to have an answer which will be negative 6 on 25 times 3i plus 4j will be the vector resolute of this force in the direction of that vector.